That the problematic is that once you are having the entire row as 0 in your Routh table, okay. So not only just the first column, first element of the of your row is 0, but the entire row is 0, like in this case, okay. So how you handle that situation and what you can interpret from that, okay, that's the second thing. Now that's the second case actually. So entire row is having 0 here. So let's first consider this example. Following this example, it may make things clearer for us. Okay, so it says that determine the stability via Routh table when the rows of 0. Okay, so you have this closed loop transfer function over here, can by S5, S7, S6, S8, and all of those. There's some noise over there. Okay. All right. So see here, what is the highest power again here? It's 5. So you start from S5 all the way down to S0. All right. Then you put the coefficients. The coefficient of S5 is here 1. Then S3 is 6. Then S0 is S1 is 8. Right here. Then for S4, it's 7. Okay. S2 is 42, and S0 is 56. All right. If you put the coefficients here. So you always look if you have any row which can be divided by some common number, you always do that. It will help you. It means it simplifies your way. Okay. For example, here is 7, 42, and 56. These were the numbers, all right? 7, 50, 42, and 56. But these all three numbers are actually divisible by 7. Okay. So we just divide by 7. So we get, what do we get? 1, 6, and 8. Did you get that? Always, if in the Routh table, if you see any row, if it is divided by any common number, okay, you always do that. Okay. So for example, like here, just give me a second. Okay. So it was 7, 42, and 56 here. So it was divided by 7. So you get 1, 6, and 8. All right. Now, now S3, this row that we need to calculate. Okay. So if you can clearly see that, this minus sign, if you take the determinant 6 minus 6, this will come down as 0. Okay. Then 1, and this first column, first column and third column are in the determinant, right? So 8 minus 8, this is also 0. So, and the third term is also 0. So this, your entire row becomes 0. You see there, okay? So if your entire row becomes 0, so it looks like you don't have any way forward. Okay, if the entire row becomes 0, obviously everything would be undefined. Okay, so how you handle that situation? All right, so it's pretty simple for that. So if the entire row becomes 0, you just look at the row which is 1 above it. So what is the row above it? S4. S4 row is here, right? So what should be the, if you just look for this S row, what should be the polynomial for it? Anyone?
What's that?
What should be the polynomial for this row? Like you have this entire polynomial, all right? If you just look at this row, what should be the polynomial? Like this. It should be S4, then this is S2 term, right?
S2
6S2 plus 8.
8.
Right?
Yes.
Let me just show you to the next, probably the next. Yes, next row, all right? So what should be the polynomial here? S4 plus 6S2 plus 8. Did you get that or not? Becomes 0. You just go one step above, like the row which is immediately above it, right? In this case, S4. You just write the polynomial for it. All right. This is S4. What value is this? This is S4. Okay. Coefficient was, so you just wrote S4 plus this should be, this is S2, right? This alternate values. What is the coefficient for the S2? Is 6, and this is S0, or just the coefficient which is S, which is 8. Okay. So if you write the polynomial, we call it auxiliary polynomial. What should be it? S4 plus 6S2 plus 8. That's the first step actually. Once you have the entire row as 0, you write the polynomial for the row which is immediately above it. Okay. All right. Let me go to the next. Secondly, you just take a difference. You just differentiate that polynomial with respect to S. All right. You just take a differential of it. So what should be the differential for it? 4S cubed plus 12s plus 0. Is it right? So what is happening here now? Now you are having a polynomial which is in the highest degree is 3, s cube, okay? So you can just place whatever is a polynomial here, uh, four coefficients 4, 12, and 0, all right? You just place 4, 12, and 0 here, okay? Again, you see here, just we cut it down because 4, 12, and 0, again, they have the common divisor, which is 4. So you divide it by 4, so you'll get 1, 3, and 0. For this case, okay? So in general, like if you have any row 0, you just look the row above it, you just write the polynomial for it, okay? And then you just differentiate that. So whatever are the polynomials here, coefficients of the polynomial, you just write it down there. So in this case, 4 and 12, you write 4 and 12 here. Since 4 and 12 are in this particular case, they are actually divisible by 4. We just make it further simplified like we did it in the above case. So we can write 1, 3, and 0. Okay. So for the rest of the values, you follow the same formula. You can just create those values and you're getting this. All right. In simple case, if any row becomes 0, okay, so you just look for the row above it, write the polynomial for that. Once you take a differential of that or differentiate that, you can get the equation of polynomial which is in the degree s cube, or the degree which is the row which is 0 actually. So you write the coefficients of that here. Only in this case it looked a little complicated because 4 and 12 are actually also commonly divided by 4, so you get 1 and 3. It's the same. Maybe in other cases they are not divided, so you can get just write the coefficients which were here. Okay, if it was 5 and 12, so you could have just written here 5 and 12. All right, so you have this situation here. Now that's the first method, okay, or the first step, that you create the Routh table. So how you create the Routh table if the entire row is 0? You just look for the row above it, write the polynomial for that, do the differentiation of that, and then write the coefficients there. Okay, that's the first step. Now how you interpret that? What does it actually mean if the entire row becomes 0? Right. Second thing of the Routh table is the Routh Hurwitz criteria is understanding the or interpreting what does it mean. So so whenever there is the entire row becomes 0, all right, there are always even polynomials uh, in your root, in your denominator, or in the denominator of the transfer function. What does the even polynomial mean?